And now it's time to build the model itself. So this is going to be easier. We're going to have like a simple dense neural network. And the first thing to do is to create an inputs layer. So we have to access tf.keras.layers.inputs. And in our inputs layer, we just have to pass a shape. And our shape, it's going to be our window size, 15, okay? Now that we have our inputs layer, we are going to create our first dense layer. And here we're going to say tf.keras.layers.dense. And our first dense layer, it's going to have 128 units and an activation of ReLU, okay? And we just have to plug our input layer. So here we are using the functional API of Keras, okay? We could also use a sequential API because this is actually, a very simple model, but let's stick with a functional API for now. So let's create another dense layer. And I cannot write today. And our second dense layer, it's going to have 256 units. And our activation, it's also going to be a ReLU. And it's going to take as input the previous layer, the L0. And finally, we just have to define an output layer. And this layer, it's going to have just one unit. So our output unit, that is somewhere here like that. So it's expecting just one output. And yeah, we have to pass the L1 and we are good to go. This is our model. It's done. We just have to pass it to our tf.keras.models.model and define our inputs as the inputs layer and our outputs as the outputs. Okay, so we can call it outputs layer. Outputs layer. And cool, we can now see the summary of the model. And we have our input layer, two dense layers, and now our output layer here. So a very simple model. Now it's time to compile it. And we are going to use like the simplest of the parameters. So we are going to use as optimizer. We're going to use the RMS prop. And we have to pass the loss that is going to be, this is just like 1 unit and it's a regression. So we can use something like the mean square error and we can use the matrix, the mean square error. Okay. And now it's time to fit the model. So our last step, and we can use like a variable to store like our, results of the model. And we just have to say model.fit. We have to pass our xtrain that also contains our input and output. We have to pass the validation data. And here we have our xval and the number of epochs, 100 epochs, and that's it. And epochs, not epoch. And we also have like typo here because, okay, sorry guys, we have to actually create the variables, the inputs and the outputs. So let's name it xtrainds. And here, let's call it xval for validation ds. And instead of passing the xtrain here, I'm going to pass the xval. And here, the shape, I'm going to pass the validation shape as well. So now that we have our inputs and outputs created for our train and validation series, and apologies for that. So we are just running this function. We didn't do it. And instead of calling it ds_train, I'm calling it ds_train ds for dataset. Same here. And now, and it's going to take a while, depending if you're running TensorFlow CPU or GPU. And after the model is trained, we can start to take a look in our X test. So this is going to be our final test. We're going to see if we can actually predict the Bitcoin prices using this data set. So the model never saw this data set, this data. So it's something different. So let's start by converting our X test that is still on a data frame format to a NumPy array. Okay, and we can take a look, and it's just like our values, but in an array, a NumPy array in this case. So let's start by writing a for loop, and we can say for I in range of 0, and then we can say length of X test minus window size. And here be careful, because we cannot loop till the end of the X test, right? Because we need sequences of 50 numbers. And if we are here, let's say, we don't have 50 numbers to fit to the model. So we have to stop our for loop before reaching the final 15 numbers. And we are also going to pass a number of steps. So we're not going to loop like through 0, 1, 2, 3. We are going to loop through 0, 15, 30, 45, and here on. And the number of steps, it's just going to be our window size. So we want to predict every 5th day, okay? And with that, we can start by taking a chunk of our data, and we are going to take from I till I plus window size. And this is going to give us some nice sequences of 15 Bitcoin prices. So let's take a look. So cool, so we have the sequences here, okay? A couple of sequences and everything looks fine. So now we have another issue, because the model is expecting batches. So we trained the model with batches of 32 sequences. And here we want to pass these sequences to the model one by one to get our predictions. So what we can do is to create a fake axis. And this axis is going to basically pretend that is like, a batch. So we're going to pass basically batches of one sequence. Okay, so let me show you. So we are going to use the NumPy new axis here. And like that, we have like a nested list here. So this make it like to be ready to be inputted in our model. So we can just call it model.predict, and we can pass our inputs here. And we're going to get some predictions back. So let's just print these predictions. And here we go. We have our predictions for our Bitcoin prices. So in the first sequence, our model thinks that the Bitcoin price is going to be 1.145. Don't forget, these values are normalized. If you want to denormalize them, it's actually pretty easy. You just have to take this value, multiply by the mean, and multiply by the standard deviation, and then sum the mean. Yeah, that's the way. So let's actually move on from here. And we don't want to have like this nested value in lists, so we are going to take the value out. We can just call the index 0 2 times. And with our final predictions, we want to check if the predictions are bigger than the real value, right? So we can just call the X test, and we take the window size plus I. So this is basically the last element of our sequence. So if our prediction for the 16th number is higher than the current number itself, we are going to actually append it to the bias. So we can say bias.append, and I just figured it out that we don't have bias yet. So we have to create two dictionaries, one for the bias and one for the cells. Okay, and here we are going to use actually the update method because it's a dictionary, and we are going to pass the I plus window size And this is going to be our key. So our X value in the graph. And we're going to pass the real value here. So the X test, and we have it here. So the last value of the sequence. Okay. And we can say if this is not bigger, so else, we can append it to the cells. So cells.update, and then we update the exact same number here. Cool. So we can just run it. Now we have two cool dictionaries, the bys and cells. So these are our entry and exit points. Okay, we can see that we have, it's a bit distributed, but yeah, let's now plot something. So let's start by creating a new figure. So we can say plt.figure, and we're going to pass like fig size. And our fig size, it's going to be something like 1610. And then we have to plot three things. So we have to say plt.plot, and we are going to plot our X test, and we are going to give it a label of Bitcoin predictions. We are also going to plot our bys and our cells, okay? So we have to give it like a X value and a Y value. So our X value, it's going to be our bys.keys. So these values here, so like we want to take an action on the third day, right? So yeah, and here on. So here we pass the cells.keys as well. And now for our Ys, we have to pass the values that we got here. Okay, that's why we, have these key pair values with the positions and the values, to map our bys and cells in the graph. So now here we can just pass the bys.values like that. So the values here. And we can do the same for the cells. So cells.values. We just have to change something because we want it to be a list in order to work with matplotlib. So let's pass lists everywhere, converting them to lists. Another list here. And this is the final one. And the final step is just to get our legend plotted, and we are good to go. We can just add a grid if you want to make it a bit fancier. And we have just a typo, it's cells, not cell. And here we go. Okay, so we don't want to plot lines actually, right? So let's actually give it some symbols. So for the bys, let's give it up arrow. And for the cells, the same, but to pointing down. You can also give it a color. So we can say that color, it's green here for the bys. And here the color is red. And just like that, we have like our plot telling us when to buy or sell our Bitcoin. As you can see, it's not like 100% reliable. This is a very, very basic model. And this last, part of the data, it's completely normal, So it's really going up like in a very, very strong trend. And this is not normal even for Bitcoins. So it doesn't do like the best job predicting, So here it starts to think, okay, no, this trend should go down. Here it thinks the same. The trend really should go down. Here it kind of changes mind and okay, it should go up, And it's not the best model, but it's a great exercise to start with data science. If you try to fit, like more data, and if you kind of try to, improve your model here, you can actually get better results. So hope you enjoyed like this introduction to TensorFlow, and hopefully you'll make some good trades. Good luck.